Hello everybody, today we are doing a question from CSIR NET December 2018. Question is from part B. The question says, let R denote the radius of convergence of the power series sigma k is equals to 1 to infinity k x raised to k. Then first option is R is greater than 0 and the series is convergent on closed interval minus r. Second option is R is greater than 0 and the series is convergent at x is equals to minus r but do not converge at x is equals to r. Option 3 is R is greater than 0 and the series does not converge outside open interval minus r. And option 4 is R is equal to 0. So let us determine which of the following options is correct. The series which we have been given is sigma k is equals to 1 to infinity k x raised to k. So for any series of the form sigma n is equals to 1 to infinity a n x minus a whole raised to n, the radius of convergence is given by formula 1 by r is equals to limit n tends to infinity mod a n plus 1 by an, and this is equals to limit n tends to infinity a n whole raised to 1 by n. Alright, so here the radius of convergence can be found by this formula, and 1 by r is equal to limit n tends to infinity a n plus 1 is k plus 1 and a n is k. So it is equals to limit n tends to infinity k plus 1 by k, and this is equal to 1. Therefore, the radius of the convergence is 1. So the radius of convergence of the series is 1. Now, if we consider this series, then if the radius of convergence is r, then r a minus r comma a plus r is the interval of convergence, that is the interval in which the series is convergent, and we have to check at a minus r and at a plus r whether the series is convergent or not. But in the open interval a minus r a plus r, the series will be definitely convergent. So here a is equal to 0, so the series is convergent in open interval minus 1 1 definitely. Then we have to check whether at x is equals to minus 1 and at x is equals to 1 the series is convergent or not. At any point outside open interval minus 1 1 closed interval minus 1 1 the series will be divergent. So now let us check at x is equals to minus 1. If x is equals to minus 1, then the series is sigma k is equals to 1 to infinity k minus 1 raised to k. So this series is of the form minus 1 plus 2 minus 3 plus 4 minus so on, and we know that this is a divergent series. So when x is equals to minus 1, the series is not convergent. Now when we consider x is equals to 1, the series is sigma k is equals to 1 to infinity k 1 raised to k, that is sigma k is equals to 1 to infinity k, and this is equals to 1 plus 2 plus 3 plus 4 plus so on, and clearly this series is also a divergent series. So the series is divergent at x is equals to 1 also. So at x is equals to minus r, the series is divergent, and at x is equals to r, also the series is divergent in the open interval minus r, that is in the open interval minus 1 1, the series is convergent. Now let us determine which of the option is correct. First option is r is greater than 0, which is correct, and the series is convergent on closed interval minus r. So we know that the series is convergent in open interval minus r. So option 1 is wrong. Option 2 is r is greater than 0 and the series is convergent at x is equals to minus r, but do not converge at x is equals to r. So this is also wrong because the series is divergent at x is equals to minus r also. Third option is r is greater than 0 and the series does not converge outside minus r. So this is true because any point outside minus r is minus infinity, minus r, union r, infinity. And clearly the series is convergent only in minus r, open interval minus r. So in this region the series is divergent. So this is the correct option, and obviously option 4 is wrong because r is equal to 1. R is not equal to 0. So option 3 is the correct answer. Thank you.